Okay, we're going to finish up section 10.1. We're going to start with this example. It says as cars age, their resale value declines. The Nissan Altima tends to hold its value longer than American cars. The data below contains the age and price of 11 used Nissans. What you can see in the table is we're listing the age in years and then the price per 100. So a 5-year-old Nissan should be $8,500 as far as resale goes. So take a minute right now and I'll have you enter this data into your iPad and then we're going to create a scatter plot from it. Once you've entered your data and you create your scatter plot, you should see something that looks like this. This scatter plot is showing me a negative linear relationship. It looks fairly strong. So now that we have that information in, we do want to go back to the spreadsheet and we're going to use the wrench tool so that we can calculate some of the linear regression information as individual pieces. So once you hit the wrench, it's statistics, stat calculations, and then linear regression. I like to use A plus BX, that's more of a statistical model. And then they're going to ask you for some more information about the X list and the Y list and where you want your results. So when I take my pieces from the stat calculations, this is the regression line that I should have. They're also asking for the correlation between the two variables. Remember, that's R. And based on the spreadsheet information, it's negative 0.9237. That actually implies a very strong relationship. But again, it's a negative linear, not a positive linear. So now what we're going to do is calculate the average price for an Altima that's 3 years old. This is not something that was in our original data, so we'll use our least squared regression line to calculate its predicted value. So I'm going to take the equation that I wrote on the last slide, and I'm going to substitute 3 in for x. And this is the value that I'll obtain for a 3-year-old vehicle. Remember, this is price per 100, so its actual cost is over $13,000. Now, we need some other information as we move forward into our sample standard deviation and our confidence interval. So I'm going to have you go back to the spreadsheet. We're going to run the 2 variable statistics. So again, this is the wrench, stat calculations, and 2 variable statistics, and they'll still ask you for some further information. We're going to look for X bar. So there it is. One of the other things I want you to look for in there is the sum of X. What they've done is they've added up all the X values that were observed, and then the squared values. So all of these should be present in the 2 variable statistics that you just generated. This is the formula for the sample standard deviation that we'll need for our regression. So you can see in this formula, I need the residuals, and then n-2 represents my degrees of freedom. Now I'm going to have you return to the spreadsheet and look at one more thing. So when you ran your linear regression, there was another cell there called resid. If you'll tap on that cell, what it will do is bring up all the residuals for all the observed values versus the linear regression line. So we will not have to calculate these by hand, which is nice because that can be tedious. I know that the residuals or the deviations should have a sum of 0. I did go out 3 decimal places, so I'm pretty close to 0. I would say that that's acceptable. But that doesn't help me. So what I want to do is square all of my deviations and come up with a sum of those. And there's the sum of the deviations for my observed value. We're going to use that value moving forward. So again, here's the formula for the sample standard deviation. The value we just produced will go in the numerator. And then we had a sample size of 11 for n. I'm going to do the math underneath that square root. And then ultimately it's going to give me a value of 12.5766. So now they want us to calculate the confidence interval for the mean response when the value of the car is 3 years old. We're going to use the calculator method this time. So what we did is we modified some of the original values in the denominator. So this is what it should look like. And the reason I had you pull some of these values is the calculator did generate the sum of x squared, and it did generate the sum of x. We also know the sample size. In the other version, the first version, there are things there that we would have to calculate by hand, and that's really going to be something we don't want to do. So let me sub in the things that I do know. So the sample standard deviation we just calculated on the last slide. We're going to fill in n, sample size of 11. Up on the numerator, x star is my 3-year value, and then x bar. And then down in the denominator, we had 326, and then the sum of x was 58, but we're going to square that. Okay, as I move forward with my calculations, I've got a numerator and a denominator, and I'm going to add. All right, so there's the value of everything underneath the square root radical, and then I'm going to multiply those values to get the standard error for the mean value. So now I'm going to use this number moving forward in my confidence interval. So here's the mean response for y. Remember, we're using a t-distribution because standard deviation is unknown, and the standard error for mu, which we just calculated. So the observed value, the mean response for y, is the value of the car when it's 3 years old. And there's the standard error I just calculated. Your t star, you're going to have to do inverse t. Remember, it's a confidence interval, so put in an area of 0.975, and degrees of freedom is going to be 9. So this is the t star that you should use. And moving forward, so we know that a 3-year-old Nissan should fall somewhere between 117.93 and 151.44. And this is the values rounded to the nearest hundredths. We're going to skip the Duke method just to save time on the video, but I also think that there might be something wrong with the formula. I did try it a little bit earlier and it just wouldn't work for me. So we'll come back to it when we actually have class. Okay, now we did a confidence interval for a value of x that wasn't an observation or contained in my data. But what if we want to make a confidence interval for a future prediction? What might be a 3-year-old Nissan be worth 10 years down the line? What you can see here is the solid line is your least squared regression line. You can see that the intervals are the dashed lines, and they're quite far actually from this regression line. That's going to account for some error that might be present. And moving into the future, there's variability there that we might be unaware of. So we need to modify our confidence interval formula to take into account the future. So the structure of it's going to look the same. So this is for a future observation. So we're looking for the response variable y when you have some value of x. And you can see the structure is similar. And again, degrees of freedom is n minus 2. In that confidence interval, we do need to calculate standard error. The only thing that's different is we have added a 1 into the equation, and this will help with our variation. But otherwise, it's the same. Let me bring up the calculator and the Duke method. We're going to stick with the calculator method for now. And again, you can adjust your formula cards to reflect this new denominator. I'll bring up the Duke method, but we're going to stay away from that. I think there's something missing here. So again, looking at the same diagram, this is our prediction interval, which is wider. It's taking into account the error for the intercept and the error for the slope and the uncertainty about what will happen in the future. So you can see that the interval is wider. So we'll be able to come up with an accurate confidence interval. It will just make the span of values for the car that much greater. All right, so the prediction interval for a future observation when x equals 3, we'll stick with that. We're going to use this formula. Again, it's almost identical except we've added the 1 and we've changed out the denominator. Let me sub in the pieces that I do know. We're sticking with our same sample standard deviation, our x star value, x bar, and the other pieces that we pulled from our 2 variable statistics. So I'm working through, evaluating certain parts. You can see this is the same as the last time. Getting a little closer. And ultimately the standard error is 14. Now we'll run our confidence interval. So for a future prediction, we're going to use the value of a 3-year-old Nissan that we calculated earlier. Looks like I have the wrong standard error from the last time. So we're going to swap that out. Oh, I did. So the 7.4 should really be 14.5956. And there's my T star. Moving forward with our calculation, you can see this margin of error here is quite a bit bigger. And there's my confidence interval. So my Nissan really in the future could be worth anywhere between 101.67 and 197.70. And there's the interval rounded off correctly. For this assignment, you're going to do 10.44. If you have any questions when you're going through, make sure you give me a call. Otherwise, I'll see you at our Zoom meeting on Wednesday.